We are going to begin our morning program that is hosted actually by our Magnet Association here in the Greater Cleveland area. Our program this morning is getting a jump start on your career with learning and earning experiences. And we have three young people who have had the opportunity to work through an internship program and or a co-op or perhaps even an apprenticeship program. And we're here this morning to discuss those programs with them and also to provide for you some valuable information with regards to internships in particular. Okay, we're about ready to start. I want to introduce the guests that we have with us this morning. And I'm going to put everyone on camera as we move from my right to continuing to move, in a sense, to the right. With us, first of all, is Amber Johnson. And Amber's actually an intern at Ashland Energy, and we'll be talking to her with her experience, an associate degree from Lorain County Community College, and also her work now at Cleveland State University as she's working towards a degree in engineering. Also with us is Daniel Pistelli, and Dan is actually with Logan Clutch Corporation, and he is a graduate.
Oh, wait, we just got connected. Okay.
Hello.
Never mind.
Hello.
Hello.
Hi.
Hi, Revere. If you guys want to get yourselves, if you want to get yourself seated, we're going to get started.
Okay, so
We're waiting on.
Notice they forgot the kid.
Okay, very good. Well, I'll tell you what, let me back up a little bit, Revere, so you can get some information from us. And our program this morning is getting a jump start on your career with learning and earning experiences. And we have three young people here who are currently employed and have actually been involved with internship programs that have provided for them great opportunities in not only experience but also in opening doors for employment with a variety of different companies. And actually, I'm going to, we'll start all over again here. Amber, we'll introduce you again, okay? This is Amber Johnson. Amber actually is a graduate from Elyria High School, and she has an associate degree in alternative energy from Lorain County Community College, and she's currently attending Cleveland State University and working through an internship with Ashland Energy. Amber, thank you for joining us this morning. Also with us is Daniel Pistelli. Daniel is actually a mechanical design engineer. He's a graduate of James Ford Rhodes High School, which is located here in the Cleveland Municipal or Metropolitan Schools, and at Cleveland State right now and doing an internship with Logan Clutch. And Daniel, thank you for joining us.
Thank you, John.
And also with us is Don Vath, and Don is actually an electrical engineer. He's a graduate of the University of Toledo and North Olmsted High School and the Polaris Career Center, which is located here in Cuyahoga County. He's working currently on his graduate degree and again with Denk Associates. And Don, thank you so much for joining us. Let me come back to, I guess, to all three of you, and we'll put us all on camera here for a second. We're talking now about mechanical engineering. We're talking in a situation about electrical engineering. I want to ask a question. What led you to this particular career, and a little bit about your background in high school? Who opened the door and sort of either led you by the hand or you took the first step to think about getting involved in an engineering field? And Amber, for you especially, and I'm going to come back to you now, women being involved in engineering, okay? There are many women, but again, it's still sort of a new career area for women.
Right.
So you were at Elyria High School.
Mm-hmm.
And were you involved in any type of engineering courses at that particular time, or was it basically science and math?
Well, I did take 3 semesters of CAD, and that definitely opened up the door. And I think the big thing that got me interested in it was I had an amazing physics teacher. I took normal physics my junior year, and then I took AP physics with that same teacher my senior year. And I think physics is probably the coolest thing ever. So I really, wanted to stay involved with that. So I ended up, now I'm doing electrical, mostly because I had a really great physics teacher, and I wanted to stay around that area. So
Okay, and you decided to start your college education at Lorain County Community College.
yeah, I got the trustee scholarship, so I had my first 2 years for free. So I thought you can't really get any better than that. So
And your associate degree is in what then?
my first associate degree that I got in December is in I think the official name of the degree is alternative energy technology. It's essentially a degree being a technician to maintain wind turbines. So that's where I started out because I was a little intimidated by the amount of math that engineering would take. But after going through that, I decided that I think I could handle it. So
Very good.
Yeah.
Well, again, thank you for joining us this morning. And we're going to come back and talk a little bit more about Ashland Energy here after we run through here with Dan. Dan, tell us a little bit about your background now. James Ford Rhodes High School, Cleveland product, and then on to Cleveland State. Was there a driving force in high school that pointed you into a direction of engineering?
I would say that I was very self-motivated from the beginning to get into some type of engineering or mathematics-based career field in the future. But I also had a very strong math presence at high school with a great math teacher at school that guided us along the way all the way from geometry all the way up to an actual calculus class. And she was a really good mentor and facilitator to set a good, strong mathematics foundation in my life. So I was able to utilize that with a very strong base and foundation and proceed to move on to go after what I wanted to.
Okay, and now you were at Cleveland State?
Correct. So I graduated in 2014 from Cleveland State with my bachelor's in mechanical engineering, and I continued on in an accelerated master's program to gain my master's of science in mechanical engineering, which I'll be graduating with this May.
And why did you choose Cleveland State for your BA degree?
Cleveland State, and especially the Fenn College of Engineering, now the Washkowicz College of Engineering, had a great foundation as being a strong leader, producing good engineering students with a lot of real-world application and practical experience. We weren't just pencil pushers or book pushers. We can get out there, get a job, and do the job well. In addition to that, I did receive some scholarships and aids through my performance in high school that allowed me to obtain my bachelor's degree with a full tuition ride for the 4 years. So coupled with the strong engineering foundation as well as the scholarship and tuition support, it was a clear choice for me to go to Cleveland State.
Oh, very good. So we've got tuition support, scholarship for you, and also for you. All right.
Absolutely.
Sweet. And I'm sure Don had some help too. We're going to talk to Don now. Okay. Let's go over to Don. And Don, again, a graduate from North Olmsted High School, and spent your junior and senior year then traveling back and forth to Polaris?
Yes, that is correct. So part of the program at North Olmsted was to travel back and forth to Polaris, where I was in the electronics engineering program, where we learned how to use our technical skills and our theory-based learning and create different, unique, fun projects that we would then put all together and create a large project at the end of our program, and we'd learn a lot while we were doing it. So
What was the impetus to get you into electrical engineering?
So I've always come from a background of tinkerers. My father's a mechanic, so I've always been a hands-on type person. He taught me how to use a soldering iron around my freshman year, and from then on I've just been tinkering and playing and
Soldering.
learning. So Polaris got me more interested in that, and then it got me interested into thinking what I wanted to do with my future, so I decided to go be an electrical engineer.
And you chose the University of Toledo?
Yes, I went to University of Toledo for 5 years. I have my bachelor's of science in electrical engineering technology, and I'm currently due to graduate in December with my master's in general engineering.
Very good. That's super. Well, again, thank you also for joining us. We have some clips here that we'd like to show you now to give you a little bit of background with regards to the different types of programs and companies that our guests here are involved with. But before I show you those, let's just talk a little bit in general about internships, okay? And the value of internships and your experiences with an internship. Don, let's come back to you now. Where did you do your internship?
I actually interned in Dusseldorf, Germany, at Mercedes-Benz. So part of the Polaris program was that we went and spent about 3 weeks in Germany, and each one of us had a different co-op to go to. So I was at Mercedes, and I worked on diagnosing technical, electrical, mechanical issues with vehicles. And then after they were fixed, we got to test them on the Autobahn. So it was a good time.
Yeah, I'm sure there was. Now, you said through Polaris?
That is correct.
That's unusual, is it not?
No. As long as you have good grades and you show an interest and you can afford the plane ticket, you can go learn in a different country. And at the time, I actually didn't speak any German. I had taken Spanish classes, and the technician I was working with didn't speak English, so we spoke Spanish back and forth to each other. So it was overall a great learning experience, and it really helped solidify my decision to become an engineer because I was so interested in the work that they were doing. So.
And now, what about an internship while at the University of Toledo?
I did not do an internship at the University of Toledo due to the economic downturn, but the master's program I'm currently in requires me to be working full time. So while I'm working and learning, I can apply that towards my master's degree and vice versa, so that it could be really a whole well-rounded education and learning experience.
Okay. And Denk Associates then signs off on that? Is that the way that works for you?
Yeah, so there's different courses that you can take through the program, and I try and gear it towards what we currently do at Denk Associates and what we may want to do as part of our business in the future. So.
Okay, very good. That's super. Daniel, what about your internship? Can you talk a little bit about that,
Sure.
please?
So, almost 2 years ago, exactly almost to this date, I, as a sophomore at Cleveland State, entered into an internship with a company called Logan Clutch Corporation. They're a small family-owned business that was founded in 1975, and they're currently located in Westlake, Ohio. So it's a very nice facility, new facility, where up front the office and out back all the manufacturing and assembly takes place. So we've got from start to finish, design to ship out the door, all in one facility in one location, which has been a great help for understanding and for learning and getting to be familiar with the entire process. So upon my graduation with my bachelor's degree, I actually took full employment with Logan Clutch, so I will be working there as my home company. And they're continuing to be flexible with me with my schedule, which has been very appreciative while I'm in school also, because it's a bit to juggle all at once. At Logan Clutch, I work in the engineering department. It's a small engineering department, but we hold our own. And for myself, I'm responsible for not only generating, but also maintaining new and old 3D models, 3D assemblies, and 2D manufacturing and customer prints of our product line. So we do fluid actuated multi-disc clutches for marine and industrial applications, and so I'll be the one behind the desk that puts together the entire package for, say, a customer requirement. He tells us what he needs. We go ahead and set forth with the engineering process, and by the end of the day we produce basically blueprints or prints that we would send out to the manufacturing, and they'd produce the part and ship it off the way to the customer.
Very good, very good. And Amber, your internship now, you're with Ashland Energy? Or I'm sorry, guys. I'm so interested in talking to you. I actually, Douglas, I probably should have given you the remote here, and I've been better off this morning. So tell me a little bit about how you got involved with Ashland.
I'm actually not entirely sure how they got a hold of me. Somebody at the college in career services actually ended up calling me about the internship, and I applied for it. But it's right next to Cleveland State in Cleveland, so that's really cool. But the actual internship itself, I am in the research phases right now, so I haven't started the project yet. But what it's going to be is I'm working with a thing called a vanadium redox battery, which are these huge batteries that you can hook up in tandem with renewable energy. It's really, really good for intermittent sources like solar and wind. And what I'm going to be doing is physically testing the batteries. They're flow batteries, which means that there is liquid involved. So there's piping and there's all kinds of things that need to be sealed so the electrolyte doesn't drip out. So pretty much once my project starts, I'm going to be working with that and doing the technical things, making sure nothing's leaking, making sure everything's diffused correctly, there aren't any concentrated points of things. But right now I'm in the research phases of that, so I've just been reading a lot about them.
Okay, and I would imagine you'll have some sort of a mentor, assistant?
Yeah, the person who I will be referring to, his name is Mike. I talk to him a lot in the office. He's pretty much the one who's been directing me what to research. I've researched various questions, specific questions pertaining to like what kind of piping we should use, the beginnings of the design process for actually implementing this, and just other various things. He's kind of my contact. I don't work at Ashland. I work at a place called Magnet for Ashland, so Mike is kind of the link between Ashland and me.
Okay,
So.
very good. Well, we've heard now about 3 individuals and their involvement with internships. Let's take a look now at the companies that you're associated with, okay? So let's come back here to you, Amber, and I'm going to bring up a video clip here. Get it up on our screen so that everybody can see it. Okay, and I'm going to make this full view here, and let's see if we can get this working. Again, this is Ashland. I think I was saying Ashland at first. It's Ashland Energy. Let's go Ashland Energy.
Vanadium redox battery is a form of a fuel cell that stores electricity. What we're looking at is to get involved in doing backing up windmills, power leveling for windmills and for solar, and doing peak shaving for power plants such as the Painesville Power Plant. So the idea of being able to take a portion of the electricity produced by either the wind or the sun, being able to store it in the battery, and through software and controls reintroduce it when it's needed, takes these intermittent power supplies and makes them be really useful. It's been called, the storage battery has been called the missing link, and it really makes renewable energy feasible and economical. The fuel cell investments from the state of Ohio will pay off very nicely because the skill sets are here and the knowledge base is here on how to build these batteries. And we expect employment to grow by 2015 here in Ohio to be between 250 and 300 jobs. We feel like we're helping America seek energy independence. We're helping to put people to work in high technology jobs and utilizing what can be all the benefits here in Northeast Ohio, but we're making renewable energy practical.
Okay, very good. That now is Ashland. And I want to ask you a question coming back to wind turbines. How did you get interested in wind turbines?
Well, I've always been interested in green energy in general. I think that the carbon emissions and all the global warming things you hear on the news are really, really incredibly important. And because I wanted to stay in the STEM fields, I wanted to do something with engineering, but I was, like I said, I was really, really intimidated by calculus. So instead of going straight into engineering, I chose engineering technology. And Lorraine County Community College is about 10 minutes from my house, and they had this degree program already set up. So it was so convenient, and it was something that I was already interested in, and it was in the field that I was interested in going into, so that's what I ended up picking.
Very good. Very interesting. Now, with regards to these batteries, are they located actually at the top of the wind turbine?
No, they would actually be somewhere either near the base of the wind turbine or located, you can even put them in grids, so just somewhere where the energy is flowing from the energy source, which could be the wind turbine or it could be a solar panel, down into these batteries, which should be hooked up to the grid or somewhere in the system.
Now, once you have your degree and you are now a certified engineer, what will be your responsibilities with regards to the turbine?
Well, this internship, I don't know if it's going to last until the end of my degree because I still have 3 more years in it. So I'm not entirely sure what my job would be if I were an engineer for this company. So.
Okay. Cleveland area, do we have a number of turbines in the area?
We have one at the Science Center. We have one at Case. Those are the 2 specific ones that I know because I've climbed those and done maintenance on them. I know that there are people interested in putting wind turbines out on the lake, which would be really, really phenomenal because the wind density is so high out there, it would produce a lot. But I know that there are a lot of logistic things that would need to be worked out with that. In Ohio, there are definitely some. On the western side, I know of 2 wind farms. You can stand on one road and you look that way and there's one wind farm, and you look that way and there's the other one. So it's actually, you want to get more out in like where there's open space, and Cleveland isn't exactly open space. So
I think as you move west and really through Indiana and Illinois and so on and so forth, you see a number of wind farms.
Yeah.
And definitely going to be a very important way of producing energy in our future. There's also one, and again, I'm not sure if it's producing energy for a couple of the companies here on off of 480, and I think it's 480 and State, or 480 and maybe Ridge Road. But there's a wind turbine there. Fascinating. Do you plan on doing some climbing?
I'd love to. I've done it before, but they usually want full-time workers, and since I'm still in school, I can't go get a job right now, especially since you have to move. I'd have to move 3 hours away to get to the nearest one that I know of in Ohio, and that doesn't exactly work with Cleveland State, so.
Very good, super. Well, it looks like you have a bright future with regards to this. And again, the importance of the internship is just amazing. We've had so many individuals that have had the opportunity of working with a company, going through their internship, graduating from school, and then having the opportunity to work full-time with that company and getting started. Okay, let's go to Logan Clutch, and let's bring up a video clip here from Logan. And let me get up here on my computer. There we go. And I want to make sure we have the right one here, Don. So we have to scroll down here to where was our
Logan Clutch. Logan Clutch.
Yeah, well, I know it's there, but that's not the one we wanted, though. We wanted the one with the fire engine, correct?
Mm-hmm.
And what happened to that one now? We had it up here before.
Just go ahead and go to our page right there where it says Logan Clutch, and you can find it on the link. Up to the left.
Is it that tab you have open up next to Ashlyn?
Up here?
Over more. Other
This
way.
one here.
Over again.
One more?
One more.
This
That
one
one.
here? Or this one?
That one. Try that one.
I
see if that
believe,
one's
I
it.
think that's, it might be. Let's see.
Thanks, Sam.
Is that it?
You don't have it up on the thing.
Yeah, that's right. Well, that's the issue here. You have to bring everything up individually, separately. There we go. And we make that full screen.
So what you're seeing in this part of the video is actually some of the manufacturing and assembly of the parts themselves. And now we're starting to get into some of the applications where our clutches would be found. So you can see heavy rescue, fire crash, the tugboats, there's the fire crash and rescue. There's a large, looks like a Caterpillar engine.
His keys is trying to figure it out. I see.
So
him
now
up
you
there.
can see the overview
Oh,
between manufacturing and design to application.
Okay. Now, Dan, you also have some pictures there, if I'm
I
not
do.
mistaken.
Yep.
Why don't we take a look at some of those pictures,
Sure.
and we can get a better view with regards to some of the products that Logan Clutch is involved with. And again, I've got to come over here and cancel our
Okay.
computer. This is one of the issues with this technology. It's a little late.
There we go.
And let me zoom in on you,
Okay.
and there you go.
Thank you, John. So at Logan Clutch, we make everything from small 4-inch diameter clutches, something that you'd see here that would go inside of a screw machine, all the way to very, very large, several 100-pound clutches with 30-inch diameters that can transmit up to a million pound-feet of torque. So we're talking everything from very large here that you would see to very small clutches, and they'd all have a wide range of applications. So we've got, of course, everything that's in the middle of it. You can kind of see some of the pictures here. And these are our power takeoffs. So basically what these do is they provide a direct link between a power input and a power output. And so it provides you an ability to turn a power source on to a power source off to whatever output that you're driving. So for example, relating back to the fire truck or the tugboat that you saw in the video, say the crash and rescue was going onto a scene and they had to turn on the large water pumps to spray down the scene, you'd be able to turn the pumps on and off from the hydraulic motor using our clutches and transmit the torque to the component that you're driving.
Okay, and the clutch is very important then as far as stop and go in all aspects.
Absolutely.
And does Logan Clutch, you're talking about large clutches, do you work at all in the area, let's say, of automobile clutches?
We do not, no. So everything that we do is going to be industrial, marine, off-road applications, so nothing that you would consider in an automotive application. These are all fluid actuated multi-disc clutch, whereas automotive applications are usually single clutch and they allow for slip, and they're manually actuated.
In going into the company, what has been probably, let's say, the most surprising aspect of your, quote, employment with the company? What did you not expect that's really turned out to be a real plus for you?
Kind of a cop-out answer, but how much I enjoy it, maybe. Honestly, you never know if you're gonna hate it or if you're gonna love it. And I like very pure engineering jobs. Very, very kind of traditional mechanical engineering. And this is an example that pulls it all together. So it's very raw, pure engineering applications, and that's what I like. So not only do I like that, but I like that I can take what I'm doing at my desk, everything that I've learned at school, and then if I ever have an issue, I can just go out to the shop, see how they're making it, see how they're putting it together. I can test it. So I can physically actually go ahead and design something from the start on the computer and see it come to fruition back in assembly, and actually test it, make sure it all goes together and works properly. So I enjoy that process a lot.
And that was my question. You are at the computer, you are designing the instrument, and then you have the opportunity to see it actually constructed, put to work, and function.
Yep, absolutely. And we even get some feedback from the customers sometimes too. So it's nice to see, hey, I did that, and the customer is sending you pictures of the application installed.
Very good. Super. Okay, let's come over to Don now, and Don's with Denk Associates, and we have some pictures, and let me bring those pictures up right now. And we had some issues before. Let's see if we can. Now, is this the downtown office that we're looking at?
Do you want to switch?
I'm sorry, guys. I'm more involved in this. I'm going to become an engineer. I'm telling you, my second career. There we go. Now, this is residence
Yeah,
at.
we don't see it.
You're not seeing.
We're
What are you
not seeing
seeing?
the pictures. We're not seeing the pictures of the videos.
You're not.
Yeah.
John, if you just want to go to the blueprint, we can do that.
Okay, we'll show. Well, we're going to try and show you a blueprint here. I'm sorry. I wish you would have said something earlier. you probably would need to reboot your equipment because we are sending it out. Okay. All right. Well, we'll come back here with the a blueprint here. Let me bring this back to our camera. And let's get Don on our video here. Now, you are seeing us, though, are you not?
Yes, we do see you.
All right, super. Very good, thank you. Okay, Don's with Denk Associates, and he has a couple blueprints here. Electrical engineering, and what are some of your responsibilities now then, Don?
I design building power systems and lighting systems for schools, hospitals, prisons, government buildings, anything that you step foot in somewhere or another. An electrical engineer, mechanical engineer, architect have all made that building safe for you to be in. And that's what I do every day.
And the blueprint that you have here?
This is a very old actual blueprint, and this is showing a power distribution.
We're going to try and zoom in on this.
So,
how close do you want us to get here?
oh, this is fine.
If you want.
Blueprints aren't actually blue anymore, so that is one thing that disappointed me a little bit when I started working. But this is a very old hand-drawn blueprint from the 1960s that would show an electrician how to properly install and wire the components to make sure all of your lights and receptacles in your school would work. And now, in the future, everything is done on the computers, so we can produce the exact same things very quickly with just being able to use your computers. On a daily basis, I will work at my computer for any given amount of time, and then I will go out to the field and inspect some buildings. I will also have to visit some different job sites. I've had to go to prison twice. I have been around the country a couple of times for some different projects. And I have also worked on schools and hospitals, a lot of retail buildings, things like that. So that's what I get to do on a daily basis.
Now, we need to clarify that you had to go to prison twice.
Yes.
Okay. You were just visiting.
Just visiting, just for the day.
Okay. Very good. All right, so we've got to look at three different companies, three individuals who have involved in internships, individuals who are involved with and greatly involved in careers of engineering. We're looking at mechanical and electrical in this particular situation. Someone who's come through a career center. Okay, another individual who has worked through a community college and now in a 4-year program, and another individual who is moved into a 4-year program, and individuals who are graduating from all those programs with the appropriate degrees. So let's turn our questioning over to you now, students, to find out what we haven't provided for you with regards to information. And again, I apologize you didn't see those videos. I wish you would have said something. I'm not sure what we could do at our end, but I do have them, and I can send them out to you if you'd like to look at them off your own computers there at Revere High School. So do you have any questions for us? Please get yourself close to your microphone. Let us know who you are with your first name and ask your question if you would, please.
Hi, my name is Jordan. My question is, what skills are important to succeed in business?
Okay, very good. What skills are important to each of you that's allowed you to succeed to the point where you are today? Amber, how about starting with you?
Patience. It's taken me, this is the second third or second summer I've been looking for an internship related to my field, and I've pretty much been working minimum wage jobs until then. So it's a lot of patience until you can find something that matches your interests and that wants to hire you. So, and being patient through your coursework, because you're not actually doing the thing you want to do, you're doing base work for it. So patience is definitely a big one.
Dan, how about you?
I would have to say a self-motivation and a drive to actually want to go out there, do the work, because as she mentioned, it is hard. It's not going to be easy, so you got to have a good sense of driving force internally to do the job and do what you want to do and get done. As well as I'd probably say some professionalism too, honestly. With us being young and other students coming into it, you want to present yourself in a professional manner and give yourself a good appearance in a professional environment also.
Okay. And Don, can you add to that?
Verbal and written skills are really important. So even though you go to school to be an engineer, it doesn't mean you don't have to deal with emails on a daily basis and phone calls. So being a polite, well-educated, young professional is very important if you want to succeed, because older generations will respect you more and be able to take you under their wing so you can learn how to properly do your job.
And again, communications being very important in all three of your different internships. Actually, in your education, because all three of you have moved in different paths and you've been successful, and therefore you're communicating with people and, in a sense, getting the job done. Good question. Another question for us, please.
My second question is, what is a typical workday for you guys like?
All right, good question. What is a typical work day? Are we an 8-hour individual? Are we working 40 hours a week? Don, let's start with you. What's your typical day?
Well, we work mostly in an office setting. Sometimes I get to travel to different parts of the country. I've been to Kansas and Florida. I also travel around the state of Ohio a lot. Next week I'll have to go down to Columbus and Cincinnati to do some field work for some schools that we're working on. But mostly we work with CAD software, AutoCAD and Revit, and we create the buildings on paper before they are created in real life. So we go through the budget process and the design process, and we make sure that the buildings will be built to local, state, and international building codes, so that the building is safe for you to be in.
You mentioned an interesting term. Can you explain what it means when you go down and you do a field trip? What are you actually doing during that field trip?
So during an existing building renovation, a lot of the infrastructure that is important for the building to operate properly already exists. So when you do field work, you go and you verify what is actually built and in place, so that if an owner would like to renovate a building instead of build a new building, they can pick a building that already would suit their needs, and we just take an adaptation to it and create what they would want. So a lot of really intense technical skills are required, because not only do you need to know if you have enough power, but you also need to know if the power that you have can be applied towards what you want to use it for. So
Very good. Thank you. Dan, what's your typical day?
Similar to Don, I work in an office environment. I've got a nice kind of workstation with a couple tables and a couple monitors set up at my workstation. And primarily I'll just work on the computer using 3D software called SolidWorks, if you're familiar. And what I'll use that to do is generate 3D parts and assemblies of what our actual product is. So before we build it, before we manufacture it, we're obviously going to make sure that every component's going to work together, fit together the right way. It's designed for the specification that we need. It's going to handle the load, it's going to handle the speed. So what we do and what I have to do is I have to go ahead and run through all the numbers, ensure that all the design calculations are correct, ensure that the components I'm designing to are going to meet the requirements of the speed and the torque. And then once we go ahead and do that with those numbers, we're going to go ahead and use those numbers as our driving force to generate the physical geometry of how the part looks, how large is it, how small is it, what material we want to use. And once we get that all laid out and we know we're good, then we go ahead and lay out 2D prints, similar, it's like a blueprint, but it's for the individual parts and the assemblies of how to make this part, what to make it out of, and then how to put it all together. So during the course of the day, I'll be working on any number of projects varying from old existing parts that are being revised, corrected, improved, to brand new customer applications where we have to fulfill the need of the customer demand.
Do you work in a team environment?
I do. So we in the engineering department, there's 3 of us, and we all work semi-independently on our work, but there's always an open line of communication, always. So if I have a question, if any of the other engineers have a question, we just go right back and forth. We all sit in the same area, so it's a very open, friendly environment to open the pathways of communication, and not only with the engineers amongst themselves, but also the engineers and the manufacturers and assemblers. So there's not that locational disconnect of a different off-site. We can directly go out there and see if they're having problems putting a part together, or they can't do something that we're trying to ask them to do. So we've got a very open line of communication. So even though we work relatively independent on the projects, we've got an open flow between all the members involved.
Very good. And Amber, let's come back to you about your workday. What's your workday look like?
I'm very part-time because I'm taking full-time classes right now, so I only come in 2 days a week right now. Right now, like I said, we're in the research phase, so it's an office setting. I sit at a computer. I've generated a couple of reports, just general reports. I do research on different physical aspects, like things that would work really well for the battery and things that wouldn't. And once the project actually starts, I'll be down in the shop actually physically testing the prototypes for these batteries. To my understanding, it'll be mostly flow tests. And I think I'm pretty much going to be on my own with that. The engineer's probably going to be upstairs doing something else, so I'm excited for when that starts.
They put the responsibility right in your lap and you can run with it.
Yeah, pretty much. A couple weeks ago, he sent me what the tests were. He said, go through these, tell me anything you need help with. Imagine it as if you were doing it on your own. So I'm probably going to be downstairs by myself.
Great experience.
Yeah.
Great experience.
Definitely.
We've got time for one more question. We have another question for us.
I'm Mason.
Wait.
I was one done. How do you use science, indoor math in your job?
Very good. I would imagine all 3 of you use an awful lot of science and math.
Yeah.
Amber?
Well, with the tests that I was looking at when this project starts, I don't remember which specific formulas I needed to look up. I know I needed volume, I know I needed flow rates for things, the speed of liquid as it goes around a bend, just that kind of stuff. It's not necessarily difficult math, but you have to know what to look for if you have a problem. So I have this problem where I have liquid that's going to be moving and I need it to do a certain thing. So I need to know what formulas I need to look up.
The conference is about to end.
Oops.
We're good.
Okay. So it's mostly just being able to figure out the question you need to answer and then finding the math that you need to answer it with.
And Dan, your math experience? Science, math, and science, I guess, in your job.
Both science and math they're integral into what we do every day. I honestly can't think of one thing that we really have to do that doesn't involve some sort of science or math. Especially being a mechanical design engineer here, we rely on a lot of underlying foundational physics and mechanics. So everything that we do for the design calculations, that's all science, physics based. You know, how much torque can this handle? How much bending can this take? How much stress can something take before it fails? What are the material properties? How does that incorporate into what you're trying to do? And even so far as to go, after all that's worked out, and you go ahead and start piecing it together with the physical geometry, now you have to figure out ways to make the physical geometry work. So you're trying to set up It's a lot of geometry, a lot of algebra to make everything work and fit together the way you want it to properly. So I really can't pick one explicit thing. It's embedded into it permanently.
And Don, what about your experience then with science and math?
I'm gonna have to agree with Dan. Almost everything that I do is based in science and math. And as engineers, we design things to work properly, efficiently, safely. But when something goes wrong, we still have to make sure that something else goes right. So even though we design buildings to be completely safe to walk in, if something were to go wrong and something were to fail, we need to know the calculations and how to predict what would go wrong and how we would stop it and put safety implements into our design. So math and science is used from the moment I wake up to the moment I go to sleep.
Yep.
So,
Very good. Well, we are just about out of time, and I want to thank Amber and Dan and Don for joining us, and also you students for joining us today. Engineering is an exciting, a very exciting career, and we have 3 individuals at different levels in their life, at different experiences with regards to engineering, and working hard on an everyday basis in order to continue their success. Math and science, very important. The opportunity to, again, be involved with an internship, and in all 3 cases, sort of taking different paths in education to get to where they are today. So hopefully you learned something from us. If you'd like to have these video clips, please just send me an email and I'll send them on to you, and you'll get a chance to take a look at them. So again, thank you very much, Revere High School. We appreciate you being with us, and we look forward to seeing you again next time round. Thank you.